So now I'm recording. So just be careful what you say, right? All righty. So hopefully, gents, you can see a whiteboard, yes? Do you have a white screen? You got to tell me so that I can't see you.
Yes, sir.
Yes, sir.
All righty. All righty, good. So what I'm going to do is I'm going to teach on this, and you're going to see as I write on it so you'll actually see it better than what you saw on the board, right? So what we're going to do, all right, we're going to talk about circles and circumference. All right. So the first thing we got to talk about is we have to identify parts of a circle. All right. And then once we identify certain things about the circle, we're going to solve problems using circumference. All righty. Does that make sense to people? All righty. So here's what we know. A circle is not made up of line segments. So it becomes a really difficult thing to do in order to actually make measurements or find measures because we don't have segments. But what we can do though, fellas, is there are certain things in a circle that are segments. So the first thing we want to talk about is the various segments of a circle, right? And this should be review work for you, right? So if I have a circle, all right, generally speaking, we name a circle using the center of the circle, right? So we would simply call this circle A. So the first thing we want to do is make sure we know what a circle is. So the definition of a circle, right, is all the points in a plane the same distance from a given point called the center. So the circle is this part itself, all right? This is actually the circle. And every point on that red circle, right, is exactly the same distance from point A. Does that make sense? I think you all knew that, right? All righty. So the first segment we want to talk about is a thing called the radius. Anybody want to tell me what the definition of a radius is? Well, we know it's a segment. So what's that mean? If I tell you it's a segment, a line segment, what's that mean? It means it's part of a line. But a segment, unlike a line, has what we call endpoints. Yes? So a radius is simply a line segment whose two endpoints are the center, right? Are the center and a point on the circle. So if I had, Gary, what would we call this circle? Gary, what would we, can't hear you.
What do you mean, what would we call this circle?
What would be the name of that circle if the center is point C? How do you name a circle?
I have no idea.
I just said it 3 seconds ago. This would be called circle C. All right, you always name a circle using the center, okay? Now, this line segment right here, we would call that line segment what? Line segment CD, right? That's a radius. How do we know it's a radius? Because its two endpoints are the center C, and a point on the circle, D. Does that make sense, guys? Yes?
Yes.
All righty. Now, I can then take that and realize that a circle has a lot of radii, all right? So this is circle C, all right? This would be a radii. This would be a radii. This would be a radii, and so on and so forth. Now, by definition, right? By definition, we know that the circle is all the points the same distance from the center. So if this is one endpoint and it goes to D, and this is a D endpoint and it goes to F, and this is an endpoint and it goes to E, right? I know D is the same distance from C as F is from C and E is from C. So what do you know about all radii of a circle? What do you know about their measures?
They're all
They're the same.
They're all congruent. They means, so if I tell you CD equals 6 inches, what do you know about CF?
6 inches.
Thank you. And what do you know about CE?
It's 6 inches.
6 inches. So there's your first line segment that we're going to talk about, right? We have a radius. A radius is a line segment whose two endpoints are the center and a point on the circle. So this line segment right here is a radius. Now, a circle has plenty of radius or radii, right? So what we know by definition that CF and CD and CE all have the same measure, right? So we all clear on radii? Hello? Are we all clear on radii?
Yes, sir.
Yes.
All righty. Next one. The next segment we're going to talk about is a chord. All right. Now, a chord is also a segment. All right. So it's part of a line. So it has two endpoints. And a chord simply is a line segment whose two endpoints are points on the circle. All righty. So if I draw a little circle here, Gary, what would we call that circle?
Circle C.
Very good. All righty. Now, if I have a point on the circle out here, I'm going to call that point A. And I have another point on the circle over here, I'm going to call that point B, right? If I draw a line segment that connects A and B, AB is what we would call a chord because its two endpoints are on the circle. Does that make sense? Now, Gary, what would I call that segment right there?
Segment B.
Well, CB, right? But what is it called?
Radius.
Yeah, it's a radius. Very good. Makes sense? Yes, no, maybe? All righty. So everybody's following this, right? So let me get rid of that. Let me get rid of that radius, right? Now, there's plenty of chords, fellas. I can take point A and connect it to point D, right? And AD would also be a chord. But now I'm going to take one. Hold on one second. All right. And look at this that I'm going to draw right here. Look at line segment DE. Is DE a chord?
Yeah.
Yes, it
No.
is.
Yes.
Yes, it is. Look, D, endpoint, E, endpoint. The two endpoints are on the circle. But how is DE different than AB?
it has point C.
Where does it go through?
Point C.
The center.
Yes, it goes through point C, and point C is called the center. Very good. So here's what we know. Here's what we know about DE. DE is definitely a chord, but it's a special type of chord. Any chord that goes through the center is called the diameter. All righty? Does that make sense?
Mhm.
So you really have a couple of different things you need to know. Make sure you know the definition of a circle, right? All the points in a plane a given distance, the same distance from a point called the center, right? A radius, right, is an aligned segment. A radius is a line segment where the two endpoints are the center and a point on the circle. And since, by definition, all radii of a circle have to be the same length. Now, a chord, AB in this picture, is a line segment where the two endpoints are on the circle. And sometimes we have a special chord, a chord where both endpoints are on the chord, both endpoints on the circle, but it passes through the center of the circle. That's called a radius. All right, everybody following? Everybody following? It's not brain surgery.
Sir.
All righty. So now let me actually draw you a picture, and I'm going to mark it up a little bit, and I'll ask you a couple of questions. So there is a circle, and then we have a center in the circle, and we're going to call the center point Q, all right? And then I'm going to put a dot here, and I'm going to put a dot here. I'm going to connect those two. We're going to call that WZ, right? And then I'm going to draw this line, and I'm going to call this Y. And then I'm going to draw this line, and I'm going to call this X. All right? So do you all see that? Yes? What will we call, what is the center of this circle?
Q.
Q. Very good. All right? No big deal, right? Somebody give me a radius. Give me, say that again?
QY. Segment
QY. Very good. Here's QY, right? All righty. Somebody give me another radius.
WZ.
QZ. Very good. Somebody give me another radius.
QX.
Yeah. QZ, right? There's a radius. Center, point, QX. Right? So I think there's one more. Is there another one? Q, W. Right? Line segment, right? Q, W. All righty. So far, so good? Somebody give me a chord. Somebody give me a chord.
WZ.
How about we try WZ? Ready? Here we got W, and here we got Z. If I connect those two, I have a line segment whose two endpoints are on the circle. So there we go, WZ. Is there any other chords?
No.
No.
Really?
XZ.
XZ. Very good. X, Z, all right? Two endpoints are points on the circle. So I would think that XZ is a chord. Is there any other ones?
YW.
YW, very good. All right, now, what is the difference, all right? What is the difference between XZ and YW and WZ? What's the difference between those chords? These two are the same type of chord. What do you know about those two? Where does W?
Or diameters.
Very good. They both go through the center, right? So if you have a chord that goes through the center, that is called a diameter. So here's what we know. We know that XZ and WY are both diameters. All righty? Does that make sense, guys?
Yes.
Hello? All righty. I don't think that's brain surgery yet, yes? All righty. Let's move on. All righty. So, here's what we know. Radii is plural of radius, right? So, all radii of a circle are congruent. What does congruent mean? Right? They have the same measure. Now, we all know that because we just did it, right? Right? Now, is there a relationship? So here's AB. AB is obviously a radius, right? And I'm going to tell you that AB equals 4 inches, all right? So AB equals 4 inches. Now, there are certainly more radii in that circle. I'm going to draw you another one. AC. Well, we know AC is also a radius. So if I said to you, how long is AC? What does your answer have to be?
4 inches.
4 inches. Why? Because all radii are congruent. All righty. Now let's do a little bit of thinking. How about I draw this one? Now I have AD. Now, how long is AD?
4 inches.
4 inches. Why is it 4 inches?
Because already.
Because all radii have to be the same measure. Now, let's take AD and AB. So I'm going to take AD and I'm going to take AB and I'm going to put them together. And what's BD?
8
What would you
inches.
call BD?
A diameter.
A diameter. Very good. Now, if AD is 4 inches and AB is 4 inches, how long is BD?
8.
8.
8 inches. We just learned ourselves a rule. Yes? We just learned ourselves a rule. Here we go. Ready? The diameter is how many times the radius?
2.
2.
2 times. So the diameter is 2 times the radius. So what's the radius? Half the diameter. So if you know one, you know the other one. Does that make sense to you guys? So you got to remember that relationship. All right, so what's the problem? All right, the problem with a circle is that it's a curve. So it becomes very hard to actually measure, right? So what we're going to end up doing is we're going to end up using segments like the diameter and the radius to help us with our measures. So what we need to remember is this, always. You have to always remember this, fellas. that the diameter is always equal to 2 times the radius, which also means that the radius is equal to 1/2 the diameter. And 1/2 the diameter is the same as saying the diameter divided by 2. Do you guys think you can remember that? All righty. So if I draw you this picture, all right, so I'm going to draw this picture of this circle, all right? So this is going to be point T. This is going to be point U. This is going to be point Q. And this is going to be point V. All right? Can everybody see that? Yes, no, maybe?
Yeah.
All righty. Now, if I tell you, right? So I'm going to tell you, given, this is what you know, right? Line segment QV equals 8. Right? If I tell you QV equals 8, somebody tell me what the diameter is. So look at your picture. QV is right here. And I tell you that's 8. What kind of segment is QV?
Radius.
A radius. All righty. But I didn't ask you for the radius. I asked you for the diameter. Well, we learned that what? The diameter is always equal to 2 times the radius. So if the diameter is 2 times the radius, all I got to do is substitute my radius in there. And what do I get for my diameter? 2 times 8?
16.
16. In this case, I'll make it inches. Okay? It's always a measure, right? Does that make sense? That's not too bad, right? No, I don't think so, right? I don't think it's that bad, do you? All right? All right. Well, let me tell you the same thing, all right? QV is a radius, so that means it's 8. Now, what if instead of telling you QV, right? Let me draw my picture again, right? Let me draw my picture again. Same picture. We're going to use the same picture, right? What if instead of telling you QV, what if I tell you, right, TU equals 14 feet. And then I said to you, what's the radius? All right, well, look at your picture and tell me what type of segment TU is. There's TU.
Board, which is also a diameter.
It's a diameter, right? So what do we know is the relationship between a diameter and the radius? Right? The radius is how much of the diameter?
Half.
Yeah, it's half. So we know the diameter is 2 times the radius. So the radius is the diameter divided by 2. So the radius has to be 14, right, divided by 2. So what's your radius? 7. And in this problem, feet. So we know this is 7. We know that QU is 7. And we know that TU is 7. Does that make sense to you guys?
Yes.
All right. How about this one? QT is 11. Take the same diagram, right? Let me get rid of all that. Let's take the same diagram, all right? This is T, U, this is Q, and this is V, right? So you got to learn to look at simply all they want you to know, right? So if I tell you QT equals 11, somebody tell me what QU is.
11.
Yeah. How come it's 11? Because they're both what?
Radius.
Congruent.
So QT is a radius, and so is what? QU. u. So since they're both radii, they're both congruent. So they both have to be 11. Does that make sense to you guys?
Yes, sir.
Everybody following that?
Yes, sir.
That's not too bad, right? No? Yes? No? Maybe?
No.
No.
All righty. So now we're going to start using what we know about those terms, all right? So now we're going to start using what we know about those terms, all right? So let me get my right stuff here. I don't want to, yesterday I got a little ahead of myself, all right? I don't want to get a little ahead of myself. All right, so now we're going to start dealing with circumference. What's circumference?
The round part of the circle?
Around like
What do you mean the round part?
Like the
It's a
length.
measure
the
of,
length of the outside.
it's a
perimeter.
measure of distance. All right? So it's how far it is to go around the circle. Now that's a lot harder to calculate than a square or a rectangle or a triangle. Why? Because in a square, rectangle, or triangle, what do we call it? We call it perimeter, right? And it's easy to measure perimeter. Why? Because those things are made up of what?
Size.
Segments. So you whip out your ruler and measure them, right? So we have a problem when we got a circle because we don't have segments on the circle. Our circle is a curve. So what we're going to use is we're going to use what we just learned about the segments, and we're going to use those segments to help us find how far or what's the distance around the circle, right? So we always represent circumference with C. All righty? Now, I don't know if you guys know this. What's D? The diameter, right? Any circle in the world, no matter how big it is or how small it is, if you take its circumference and divide it by its diameter, you get pi. Do you know that, Gary? So, how many guys play basketball, right? What's in the middle of a basketball court? Where do you jump ball at? The center circle, right? Yeah, the center circle. You ever see a quarter? If you put a quarter on the table, it looks like a circle. Why? Because it's a circle. What's the middle of a soccer field? A big circle, right? Each of those circles, the circle at the middle of the soccer field, the circle at the middle of the basketball court, the circle on the quarter, right? If you took the distance around the circle and divided it by its diameter, you get pi. So that's where pi comes from. So every circle, this has to be true, right? Now pi, we can estimate pi to be what? What's your estimation for pi?
Isn't it 3.44?
3.14. That's an estimation. If they say, if you ever see the word exact, that simply means do not change pi to 3.14. Just leave it like that. Does that make sense? All right, so now that we know that, we're going to use this formula to help us find the circumference, all right? Now, if I look, let me do, that one's kind of sloppy, right? Let me do that again. The circumference divided by the diameter is equal to pi. Hector, Victor, if I said to you, get C by itself, what would you do to both sides of that equation?
You would multiply both sides by the diameter.
Very good. I would do the inverse operation. They would cancel, and I'd get C equals pi D. Now you have your formula for circumference. C equals pi times D. Now, let's see who's thinking. What did we say D was? What's the other segment we talked about earlier?
Radius.
Radius. What's the relationship between D and the radius?
D is 2 times the radius.
Yeah, D is 2 times the radius. So somebody tell me, if I know D is 2 times the radius, can't I actually substitute 2 times the radius? So now what do I have? I have 2 formulas that I can use to find the circumference of a circle. So if they give me the diameter, I just go diameter times pi. If they give me the diameter, all I do is take the diameter, multiply it by pi, and I get the circumference. If they give me the radius, all I got to do is take the radius, multiply it by 2, and then multiply it by pi, and then I get the circumference. It's the same formula, you're just using a different segment. And which formula would you use? Whichever one you want. But generally, it's based on what they tell you. So, for example, e.g. means for example. I say to you, I have a circle, and the diameter of the circle is 79 feet. What's the circumference? All right, so which of those 2 formulas are you going to use?
C equals pi times the diameter.
Well, they give me the diameter, right? They give me the diameter, so I might as well just use the one. So I know that C has to be equal to pi times the diameter. I take out my calculator. I can go 79 times 3.14. What do you get when you do 79 times 3.14? What do you get?
Well, what is it? 79 times what? 3.
3.14. All right. You should get about 248.119. All right. Does that make sense? Hello.
Yes.
All righty. So there you have it. That's really not that hard to do. All right. Now, if they had said, tell me the exact circumference, you would have left it at 79 pi, because pi as that symbol is an exact number. Okay? Does that make sense to you guys? Hello?
Yes.
All righty.
Yes.
Let me try something else. Let me give you another problem. Only this time, instead of giving you the diameter, I'm going to give you the radius, right? So I have a circle, right? Let's do it in red, right? I have a circle. Let me give you the radius. I have a circle, and the radius is 2.5 inches, right? What's the circumference? All right. Anybody want to try and give me an answer? Why don't you work that out and give me an answer? Which of these 2 formulas do you want to use?
The second one.
You can use the one on the right. If you wanted to use this one over here, though, what would you have to do first? If you know the radius, do you know the diameter?
Yes.
Yeah, because it's what?
2 times.
2 times. But we're not going to do that. We're going to use this one here. Ready? So all we're going to do is write down the formula. Circumference is equal to 2 pi r. So the circumference is equal to 2 times pi times 2.5. Now, multiplication, right? If you're multiplying 3 numbers together, it doesn't matter which 2 you do first, right? What property do we call that?
Distributed.
Look it up. What's 2 times 2.5? If you had $2.50 and doubled it, how much money would you have?
5.
There you go. So the circumference is 5 pi. But I'm going to change pi to 3.14. And what do you get for your circumference? About. You guys don't have your calculators with you? Get about 15.71. Does that make sense to you guys?
Yes.
Yeah.
All right, now, try this one on your own, right? Try this one on your own. The diameter of a circle is 16 feet. What's the circumference? Off you go.
Would it be 50.24? Oh, son.
Yeah, 50.27 feet, right? So our formula is going to be what? Pi d, right? Pi d. So I'm going to substitute, right? If you look up, I substitute 3.14 for pi. I substitute 16 for pi, and then I just multiply them, and I get 50.27. Does that make sense?
Yes, sir.
I don't think that's too bad, right? You guys following this all right? So we've done a lot of work today so far, right? So here's what we know. We talked about what a circle is and how to name it. We've introduced the idea of a radius, right? We've introduced the idea of a diameter. Before we introduced the idea of a diameter, we had to actually understand what a chord was, because a diameter is a special type of chord, right? Then we talked about circumference, right? We talked about circumference in relationship between the circumference, between the radius and also with the diameter. And then we had to have a little bit of an understanding about pi. And using all that info, we're able to find the circumference of a circle when we know either the diameter or the radius. So you know for a fact that you can find the circumference of a circle if you know either the radius or the diameter. Does that make sense? Yes?
Yes.
All righty. Well, fellas, if we can find the circumference when we know the diameter or the radius, I wonder if we can find the radius or the diameter if we know the circumference. What do you think the answer is, Victor?
We can.
Of course we can. Ready? So watch what we can do. Ready? So here's what I know. I have a circle. And in that circle, the circumference equals 106.4 meters. All righty? If I said to you, what's the diameter? All righty. Use the formulas you've been given. What's the formula for circumference that uses diameter? Does everybody agree with that? Yes?
Yes.
All righty. So now what we did in the last problems we did, we knew what pi was, and we knew what the diameter was, and we just multiplied them together and got the circumference. Well, here's the difference. Take what we know. What do we know? We know that C is 106.4. I know that pi is 3.14, but I don't know what d is yet. Let's keep d. How about we keep d? Let's keep d green. Because the question is, find d. All righty. What do we do to get d by itself? 3.14 times d. What's the inverse of times?
Divide.
Divide. So all we're going to do is divide this by 3.14. Now, in algebra, whatever you do to one side, you got to do to the other, right? So over here, they cancel out, and you are left with d. And now if you take out your calculator and you do 106.4 divided by 3.14, what are you going to get? About what do you get? Hello?
I'm trying to
30.
You guys,
33.87.
yeah, 33.87. All right, so it's the same formula. It's just that the given is a different number. Does that make sense to you guys?
Yes.
All righty. So far, so good. All right. Now, what if I take the same question, right? What if I take the same question, right? Let me just get rid of all this, right? Let's take the same question, or let's not the same question, the same given. I have a circle, and the circumference of my circle is 106.4, right? And I say to you, what's the radius? Well, what did we just figure out the diameter was?
33.87, right?
All righty. Hey, fellas, if you know the diameter, don't you know the radius?
Yeah, you gotta divide it by 1/2.
Yeah, all we got to do is what?
Divided by
By
1/2.
2.
The radius is equal to the diameter divided by 2. So if I know my diameter is 33.87, all I got to do is divide that by 2. And if I do that properly, I will end up with the radius. So what do you get? What do you think you get? Hello?
16.9.
16.94.
Yeah, 16.94. Very good. All right. Let's do one more of those and then we'll be finished for the day. All right. You guys doing good work today. So hang in there. Ready? So I got a circle. And the circumference of the circle is, let's do that again. I got a circle. The circumference of the circle is equal to 77.8 centimeters. Tell me the diameter and tell me the radius. Go. Anybody come up with a diameter yet?
24.7.
Is that what it is?
Yeah,
That's what I got.
8.
24.7. All righty. So if my diameter, gentlemen, is 24.7, what's my radius?
12.35.
12.35. Very good. All righty. Does that make sense to you guys? Yes? Are we good?
Yes.
Anybody have any questions on what we did today? Anybody? All right, so this will be posted again. So in case you forget something, you can go back and look at it. All right, won't be posted till this afternoon. All right, so here's what I'm going to do. I'm going to download a worksheet for you to do before the end of the day Thursday, not all of them, right? All right, so just be careful and make sure you only do what I ask you to do, right? But I have to look at the worksheet and I'm going to put it on Blackboard. Is that understood? Yes?
Yes.
All righty. Anybody have a problem? Anybody really confused or anything? I think that was pretty straightforward today, right?
Yes.
All righty, gents. I have office hours at 2 if you want. All right. So you guys can have a good day. All righty.
All
All
right.
right.
See you, coach.
All righty. Have a good one. All right.
Mr. Forward,
Yeah.
real quick. So for like, let's say for the test, like I gave it to Mr. Rumbolsky by email.
I got it. Yes. He
No.
sent it to me.
So like in future things, like feel like I use the cam scanner like to whenever we need to write it down physically, a homework, like a